Twitter sentiment analysis. Before I started, let me make sure that you can all hear me. Can you hear me now? Hello, can you hear me?
Yes, I can hear you, sir.
Okay, right. So what we'll be doing today is we'll walk through a kind of small project on how we can do sentiment analysis on Twitter dataset. And the dataset is, I will share the link here with you. So this is actually the dataset from Kaggle. So you can see it here. So if you look at this, this one is Amazon Alexa review. Okay, sentiment analysis. You can see there are many notebooks here on this review data sets. So we're gonna work on this for your assignment. I mean, for practice, I will give you a separate data set I will share with you that you can practice. But this one we are going to use is for Twitter. Now, so you all know what sentiment analysis is. You know, before you start doing any machine learning project, as I've already explained in our previous session, is the first thing is we need to understand the project, the problem. What are we going to do? So this task is sentiment analysis. What is sentiment analysis? So the task of sentiment analysis is like given a text, determine if the text is positive sentiment or contain negative sentiment or neutral in some times. So for example, if I said this is a good boy, or this is a good school, this is a bad phone. So you see, this is a bad phone. The sentiment toward this is negative because it contains some kind of negative connotation in it. So why sentiment analysis? Because if you look at it like in maybe Twitter, we may have a company or on Amazon, for example, and we may have millions of reviews. So a company will not go to try to see each of the reviews, try to find out what negative comment about their product. So we can employ sentiment analysis to automatically analyze millions of texts and find those texts that they have negative opinion, so that a company, if, for example, in a review, someone say, oh, the phone battery is bad, then when the company analyze all the sentiment, they will realize that, oh, people are saying their battery of the phone is bad, so they can actually make their battery better. So in essence, sentiment analysis is trying to find opinions in a given text. And this is one of the active research in NLP in general. People really, there are really many research in this area. In particular, what I'm working on, I'm basically working on sentiment analysis as well. So one of our recent project is called Naija Senti, Naija Senti, which is basically Naija Senti as NLP. Okay, right. So I will share the link here. I have the link. Maybe let me put the link from another source. Naija Senti. Okay. I don't know why GitHub has not. So this is the link. Oh no. Okay, so let me say Hausa NLP GitHub. So if we go to Hausa NLP here, this is our research group for. So you see, one of these projects is where we have a project called Niger Senti. So which is basically, it's an open source sentiment and emotion corpora for former Nigerian languages. So the languages involved are Hausa, Yoruba, Igbo, and Pidgin. So we have like a corpus that is annotated into a tweets that were annotated into positive, negative, and neutral. So someone that is using maybe masters or something like that can use this corpus. They are basically available for anybody to use it. So this is actually one of the tags for sentiment analysis, but I'm not using it right now. What I'm using is I'm using a different Twitter corpus, and you can actually use that as well. So if you look at it here, you can see that we have like a paper, Niger Senti, and we have different corpus. The first one is manually annotated Twitter sentiment dataset. So if you click here, what we can see here is that we have data set in Hausa, Igbo, Pidgin, and Yoruba, and we have positive tweet, this is the number, negative tweet, this is the neutral, and in fact, we also have the tweets are classified into code mix and non-code and monolingual. What we mean by code mix is sometimes you can see a tweet in Hausa, but it's like that is English. There is combination of Hausa and English. That is called code mix. So the percentage of code mix in this Hausa tweet is this, and the percentage of monolingual, what we mean by monolingual is that the tweets that are only in Hausa, they are this. So this is actually free and open source corpora that can be used for research in sentiment analysis in Nigerian languages, for example, Hausa, Igbo, Pidgin, and Yoruba. So these are different ways you can get the corpus from here. This, if you are using Python, you can generate it. If you are using R, you can download the data set. We put the code here. Not only that tweet, but also we have manually annotated sentiment lexicon. So here we have sentiment lexicon also available in Hausa, Igbo, and Yoruba. So these are manually annotated. We will give people tweets and they annotate positive and negative word in the tweet. So this is also a good data set that somebody interested in sentiment analysis can do that. But also we have other stuff, semi-automatically translated emotion lexicons. So we have some kind of emotion lexicon that we actually automatically translate using Google Translate, but we give expert translators to actually verify the translation and do correction. So for example, for Hausa, what we mean by emotion lexicon, these are words that are classified based on emotion. We have anger, anticipation, disgust, fear, joy, sadness, surprise. So for Hausa, we have this word that anger, this one anticipation, disgust, and something like that. So these are also a good data set for somebody that can do that. So we have large scale or level Twitter sentiment couples that can be used also for sentiment analysis. So this is a good couples that somebody that's interested in sentiment analysis can do that. So let's dive into what we can do. So sentiment analysis, the first thing first, before we start doing anything, as you know, we need to import our libraries. So this is the pandas, as you know, NumPy, Seaborn, which is used to generate graph and matplotlib. So this is basically what we have been doing to import these libraries. Now we import that, and I have my corpus, my dataset, Twitter dataset, and I have read CSV, as you already know that PD that read CSV to read our dataset. So now I read my dataset, and now here I save it in DF, and you can see here now I want to load the dataset. So here I load the dataset, and now you can see here this is the dataset. So like datasets in kind of pandas data frame, this is the ID, this is the tweets, this is the label. So here is a tweet user when a para is dysfunctional and the label is 0. So when the label is 0, it means this is okay. So there is positive and negative. So when it is 1 is positive, when it is 0 is negative, something like that. So we have two kind of level. Remember in machine learning, we basically have some futures and level, right? And this is what we are trying to predict. So the main task we want to do in the sentiment analysis is, given a tweet, predict whether that tweet is positive or negative. So 0 means negative, and 1 means positive. So this is basically the task of sentiment analysis. There are many variant sentiment analysis, but at the basic level, this is what we want to do. This is not like somehow the highest level of sentiment analysis. There are different ways to do sentiment analysis, and the most complicated ways. But what we are doing is just basically the simpler one. So it means this column, the ID, which is basically telling us this is the number 1, this is the number 2, number 3. This doesn't have any impact in our data set. So we may remove this column and we go with this level, what we want to predict, and this is the text. So going over, you remember, given any data set, what we need to do, if you are given a data set, what you need to do first, for example, is just like try to see what is all about the data set. We have seen info in the previous session, which tells you about the data set. So this is telling us, okay, this is a data set. It has this 3192 entries. So we have this, and 0 to 31961 column, and the data has 3 columns. So the first column is ID. We have the label and the tweet. It is telling you the data type, the null type, and stuff like that. So this is basically info that allows us to see some information about data set. Now, we have describe function. We said, okay, right, let's describe our data set and see what it entails. So when we do the describe, we can see basically the count. This is the number of the count of the level. This is the mean of the level. This is the standard deviation mean, and some stuff like that. So these are really kind of some statistical information about the corpus that may be useful in some ways. So let's look at the tweets. So you see, if we said tweet df and we call only tweet, it means if you look at this one, this is our corpus, right? Tweet df, and we have a column called level. We have a column called tweet. Now, when we call tweet df tweet like this, it means it will give us the column for the tweet only. So these are the tweets. So you can see these are tweets. But as I told you, we don't actually need the ID column, so we can drop the ID column. So this is way in pandas to drop ID, a particular column. So when we call our data set tweet df.drop, then we need to specify the column, which is the ID, and the axis. So the axis is telling us where do we want to drop. So here, when we say 1, it means we are trying to drop the axis column. So this means that now when we run this, our data set has only 2 columns. We drop now the other column. So let's look at it now. Tweet df. So let's look at it now. Right. So you see now, this is our data set. So we have the level, we have the tweet. Now the task of sentiment analysis is you will be given level for each tweet, or maybe that they will say positive, negative. So given this tweet, we want to predict whether it is positive, whether it is negative. So this is a task. So how do you determine whether a tweet is positive or text is negative? So for example, if I say, this is a beautiful car, this is a beautiful house. So this you can see is positive. So we have some features which is good, beautiful, that determine this text is positive. But when I say this is a bad car, this bad is actually, this tweet is negative. So what we expect is this kind of bad to be identified, classified as negative, and what is good to be classified as positive. This is just the task of sentiment analysis. Right. So before we go into data exploration, let's ask questions. So any question before we move on? Anyone with question? we now have just seen the data and we prepare the data before we move on. Any question?
Okay, Dr. Shamsu.
Yes.
Good afternoon to you. Is there any tendency of getting more than one sentiment in a sentence?
Oh yeah. So
Okay.
yeah.
So how do you go about that? Oh, yeah, the stage of.
Yeah. So
Okay.
so we have what is called mixed tweets. So for example, I think what we do in the task of sentiment analysis, which is difficult task. So for example, in our corpus that we're gonna release called Niger Senti, we employ people to annotate the corpus, manually annotate the corpus. So we give them tweet. But you can see here we are positive, negative, neutral. But our data set, we have mixed. So a situation whereby I love this house, but it's too far. I don't like it. So you can see this one has some positive and negative, right? But this is difficult to predict. It's some kind of subtle task of sentiment analysis. So wherever we have such kind of mixed tweets, we filtered them out from our data set. And now our data set is only positive, negative, and neutral. But you can also do this task of figuring out whether tweet is whether text is mixed. Yeah. So at the basic level, sentiment classification, people do it maybe in two ways: positive and negative. Only positive and negative. Some move further; they do it as maybe three-way classification: positive, negative, and neutral. Some even go further to do what is called not only to classify tweet, but also what we call aspect. So you determine what is aspect. But this is some stuff related to research and sentiment. So yes, of course, you can do classifying of tweet into mix. So you can give it class. For example, you can say, okay, the level if a tweet is positive is 1, if the tweet is negative is -1, if the tweet is mixed is 2. So you can do three-way, not binary classification, but what we call multi-classification, multi-level classification. So we already discussed in our previous session that classification of different kind. You can do what is called binary classification. Binary classification is a classification that classifies two things, this and this. Example, positive and negative. This is called binary classification. But we have what we call multi-level classification, where you have maybe multi-class 3 classification: positive, neutral, negative. But also you can also have positive, neutral, mixed, and stuff like that. So whatsoever, it depends on how you frame your problem. Yeah. So Dr. Saneo, can you take joining them? Right. So any question before we continue? Right. So before we continue, for those that just joined, what we are doing today is the task of sentiment analysis, Twitter sentiment analysis, which is basically the task of given text to classify that text whether it's positive or negative. And what we do, we import our data set and we load our data set. We saw our data set, which is basically the data set come with column ID, the level, the tweet. The tweet, given a tweet, we want to predict the level. And this ID is nothing in our data set, and we say, okay, let's drop this column because it's not interested. Then we saw the information about the data set, we saw the describe, and now we drop the column using this section of code here. We drop the column. So here we use this fundus drop. You provide the column you want to drop, which is called ID, and the axis here. So now this is our data set, and we prepare the data set we want to move on. So if there is no question, then we can move on. So if you remember in our steps that we discussed previously in our first session, how to do machine learning steps, the first thing is to understand the problem, right? So when you understand the problem, the thing is, as you know, is to like do what we call data exploration. So data exploration is try to explore your data. What we did also previously is somehow kind of data exploration to see your data, how it is. So here we use Cvon, which is Python library to see our data set. So here it actually shows us that there is no any missing value, null value. We can see it here. We draw. We use also hist function in Python, where it shows also, okay, these are the tweets with 0 levels. These are the number of tweets with 1 level. So you remember we have 2 classes, those tweets that are classified into 1 and those tweets that are classified into 0. So you can see this one are large because we have this, the number of them. This is, we have few of this class. So this is called data exploration. We also use, here we use counterflow, Seaborn. It still shows us the default, the data set, how it is. Right. So what I want to do now next is to try to find the length of each tweet. So for example, you remember I have the level and I have the tweet, right? So I want to find what is the length of this tweet. What's the length of this tweet? So this code, you can see it here, the tweet df length. This will create a new column called length in my data set. And here I have this is tweet df and tweet apply length. So this is telling us that apply the function called length on this column. So this length is a function. Apply is a way in pandas in which you apply a function to a particular column. So this means that this is a length function which counts the number of character in a particular column. So in Python, when you do apply and you say this, it will count the number. So here, when we run this, then we create a new column called length, and now the number of character in each. So we have the length of this tweet is 10212. So here now I create a new column called length. Maybe we will see, we'll do some kind of stuff along the way. So this is all about data exploration. So in machine learning, this is a good a prerequisite step before you start doing your training machine learning model. You need to understand your data and try to do some stuff. So this is what we are doing. So now let's read call describe to see our data set and stuff like that. So you can see now when I call describe, I have a lot of things. So number one is okay. Do I run it? Okay, let me run this one again. If you have questions along the way, feel free to ask before we move on.
Hello, sir.
Yes.
Good afternoon.
Yes.
Sir, mine is not a question actually, it's a request.
Mm-hmm.
That please you kindly upload the video today so that we can access it later in the night.
Yeah, sure. Inshallah, today I will upload it.
Thank you very much.
Mm-hmm. Yeah. So you can see here, this is the level, right? This is the level, right? This is the level. This is the length. Because when you run this describe, the describe method only works on columns that are numerical, because this is a character column. So it will work on this and this. So you can see that we have level and length, right? So it means that, for example, now the minimum length is 11. So you can see that now, because we have like the length of the tweet, we have from 1 to like 3,000, something like that. You see, you cannot go into one of them to find what is the minimum length. So you can see using this describe method, it shows the minimum length in the tweet, which is 11. Maybe the standard deviation, the mean of the length, the count, what is the total count, and the percentile here. So let's look at let's just look at the tweet with the length 11. So you can see here I say tweet df. So here tweet df length that is equal to 11. So here I am subsetting. I say, okay, this is this data frame. Give me the length of tweet that is 11. And now we have tweet ilog. So this will return this. Okay, this is it. It returns the tweet here. So this is basically we're trying to see, okay, what is the smallest tweet in our data set? This is this one. So we discussed a lot of how to subset this in pandas in our previous Python sessions. If you forget how to do it, you can go back. So this is some ways to do that. So let's go on. We have what is called word cloud in Python. So we have not yet moved to training the machine learning. We are doing what is called data exploration. we are just seeing our data, trying to understand what the data is. So there is what is called word cloud in data exploration. Word cloud is basically a kind of thing that allows you to see most occurrent words in your data. So let me show you word cloud. Okay, yeah. Okay, I don't have it. Okay, let's see. Let me go back. So okay, so let me go again. Right. I think I delete something here. Right. So here we have something like this. So who can tell me what this line of code does? Who can tell us what this line of code does? Who can tell us what this line of code does? Zaradin, what this line of code does?
I'm trying to.
Okay. Falalu, what this line does? Falalu.
Yes, sir.
And Gamana, we want a line yake.
So this line,
Shi fa dai.
the first, na farko za mu je mu selecting din column level.
Okay, so mun yi selecting column level kenan ko? Wannan kenan column level. Okay, mun yi selecting column level to.
Annan da muka dauka sai mu je mu duba if wannan column din is it equals to 0?
Okay. Okay.
So sai ya zama abinda aka samu a nan sai zama index na shi data frame din da muke ciki, saboda haka sai returning din value sai mu ajiye a cikin positive.
Okay. Okay. So in essence, what me yake yi kenan in essence?
To wannan ce ba dai.
Okay, who can give us an answer? So may I say like so we are filtering all the tweets that have level equals to 0. Is that correct?
Haka ne. True.
So we are filtering all the hello? So we are filtering all the tweets that their level is 0. So all the tweets that they have 0 as a level, they are positive tweets. Here, I'm filtering all the rows, all the tweets that they have the level as 1, which is they are negative. So 0 means positive and 1 means negative. Do you all understand this subsetting? So in Python, what we have here, so tweet df level equals to 1 will return all the level that rows that have level equals 1. So we put it as a subset to tweet df. So this is how we do subsetting. If you forget this one, you can go back to our stuff. So this means that now we have our tweets that are positive. These are the positive tweets, and these are the tweets that are negative. Now, what we can do is tweet df now is we can do what is called to list. This one we will actually so we have tweet df, we have tweets, which is the column, and we might convert it into to list. So it means it will be like a list. I will show you. So let's run this, and now we put all the tweets into a form of a list, and now we find the length of the sentence, the length of this one. So let's look at this one first. Let me remove this. Okay, let me run this one first. Okay, so tweet sentence here. If I do this sentence, let's go to Gwari Gwari. Let's do it Gwari Gwari. So can you see sentence here? Now I take the only column of tweet, that is this column tweet. I only, but there is a function. Now when I have this to list, so let's look at what will happen now when I have to list. Let's see what will happen now. So when I run this again, okay, now let's look at what will happen now. So you can see before I do to list, you can see I have all the tweet in column, right? Per row. So when I run the to list, what will happen? Let's see. So you see here, the tweets are now all put in kind of a list. Can you see the first one with this, and the second one, the third one? So they are now in form of a list. So they are now saved in a sentence. So what I want to do is this. I want to put all the tweets in like a single, in a list. So now I run this length, which find the length of the list. So we have like this number of tweets. So here, this is the first one. This is the second one. This is the third one. This is the fourth one. So we have tweet something like that. So I just change this from the column to the list, and then because I want to do something. So anyone with question? So this is basically what we discussed in our Python sessions, how you can do list, convert your data frame into list and stuff like that. So this function to list, put your stuff into that. So any question before we move on? So here I want to put all these sentences that are into list into one string. So I can use what is called join, which is a function in Python. I have sentence, I have join. So sentence is what returns those lists, and now can use this join and now put them into a single stuff, into a single string. Now when I run this, so you can see when I run this, so basically what I want to do is this. So you can see all the tweets now, they are in one giant one string, one giant string. So basically what I want to do is this. I have tweets, right? I have a tweet 1, tweet 2, tweet 3, tweet 4, tweet 5. So what I want to do basically is this. I want to do this. I want to combine, put all the tweets, tweet 1, tweet 1, tweet 2, tweet 3, up to tweet n. I will just want to put them, concatenate them together. This is the basic idea. I want to do what is called word cloud. So for me to do that, I just pick only this column. When I pick them, I put them into a list, and now I join them using this function, join. So this is a function in Python that actually joins stuff together. For example, I mean, you can check it. It's basic Python function. So let's move on. So you can see now we have a gigantic string, one put together. So let's look at what we can do with that. So you can see I'm scrolling because this is like tweet neguda dubu talatin ko dona dubu uku ko dona something like that. You can see it there. So I want to do something. So I want to do what is called word cloud. So I need to install one Python package called word cloud. When you install this, install word cloud. Now I install this called word cloud here, and let's look at it what we can do. Now when I install the word cloud, I can now import word cloud as we normally do in Python to import a package, install package. Oh, come on. So from word cloud, import word cloud. I now specify the figure size I want to plot. Now I say, okay, plot this word cloud. I call the function called word cloud here, generate and sentence as one string. So this is the giant sentence that I created. I put everything together. I only pass it here, but this line is just to say the figure size is 20 by 20, and this is how you call the word cloud object here, and now you use this function generate word cloud using this string. So this is your word string. So this is called word cloud. It basically shows you the most used words or terms in your data set. So for example, if you can see that it's happy, right? Because you can see it's a tweet, some people are birthday, thankful, user. Why do I have many user in my data set? The reason why I have many user in my data set is this. Look at how my data set is. The way they transform it is like, you see, if you have a tweet, you will have like at Musa said something, but they removed that Musa because of security reasons, and they put all user at user at user at user. Can you see that? At user. So at Muhammad Buhari, at Yakubu, they all removed the names because of security and put it as user. That is why. So the essence of word cloud is basically it will tells you what is people are what are the most common words or some common stuff in your data set. So this is one stuff in actually in data analysis that is being used, but this is not actually yeah, even in sentiment analysis, some people will try to
Yes, I think we did it.
yes, Paul, what do you say?
Yes, we did it during our Coursera course on.
Hello, Falal. Hello.
Yes, Doctor.
Yes.
I say this was one of the mandatory exercise during our Coursera course.
Okay, Python Coursera, right?
Yes, yes.
Okay, good, good. Okay, so good. So this is one way to see that. So now we are now have seen. So what we can do now is to move to our work on doing right. So now we have done what is called data data exploration. We have seen our data now. So you see, okay, your data set are this, they have many users, you have many stuff, you have explored your data now. The next thing in machine learning is to do what is called data cleaning. So now given the tweets, we will not just go ahead and start doing sentiment analysis. There are some steps that you need to follow to do that. The first thing is to remove punctuation from text. So for example, if you are given a tweet, for example, for example, if I'm given a word like this, and this man is mad. He killed the girl. So you see, there is some punctuations here that may not necessarily be useful for machine learning, like punctuation mad, like girl, like full stop. Now, these punctuations, if we remove them, this is still negative, right? So if I want to do machine learning to tell me, is this negative? This is still negative. That means that whether there is punctuation, they don't add any information to your text. But remember, in machine learning, what we do is we have what is called features in each column, right? So if you have punctuations, so for example, now if I have this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 alphanumeric, and this will all be feature in my machine learning. This will be a feature, man will be a feature, this will be a feature, this will be a feature. So you see, if you have more text, this punctuation will add your feature to grow large. So it's better we remove all these punctuation in our data set, so that instead now we have like 10 features, we have 8 features, because they will not add anything, but this word will make anything. Anyone with question about this? So the next step is, how can we remove punctuations from our data set? That is what we are going to see. So In Python, we have what we call string, right? So we import the string, and this is called this string punctuations. When we run it, this is from Python. So this is string punctuation. All this from this inbuilt from string punctuation, these are them. So given any text, before we do like sentiment analysis or any text analysis, we may remove this kind of punctuation. But this is not true for like maybe in some kind of deep learning, because they may not necessarily want you to remove them. So yeah, so we want to remove them now. So let me show you how we can do that. So given a text now, I love AI and machine learning. So you can see now here we have like $sign, I have like and here, and I have this ... So I need to remove them from my corpus so that the data is in good shape that we can do machine learning. So what can we do now? We need to use this list comprehension. I believe we all know what list comprehension is in our previous class. So let me go on like this, maybe. How list comprehension works is this. So this is, okay, let me ask somebody can explain this. We do this in our Python class. Who can explain what we are doing here? Who can explain it to us?
Okay. Here we want to create a list. Hello?
Okay.
Yes, we are creating a list. Now, the syntax is we first create a variable here before foo, then we iterate through test. Yes. So for any character in test, so we have test here with this language, this sentence. So we iterate through each and every character in the sentence. Then we test if the character not in the list here we have above. The list here we generated using string dot punctuation. So every character which is not in this test, we need it. So we use this char.
Okay. Yes. Okay. Good. Good. So what we are doing here is this. So you see, we have characters here, which they are called in string punctuation. And now here I have like let me go through this it. So I have a text, which is a variable here. I have this. So what this is doing is this for car. So here you can change it for any for X or maybe anything. Here we already explained this one in our Python session. So what we have here is like okay, let me remove this one here. Let me remove X here. So for list comprehension, how it works is this: for X or anything, you can put any for X in the variable you want to test, which is this in this. So for X in text, that is for X in test anything. So X is I, L, O, V, E, I for anything. If car, so if car, that is Y. If Y, not in string manipulation, that is not in what you give here, then return the Y. Can you see that? So this is how list comprehension works in Python. If you don't know how this comprehension works in Python, maybe you can refresh your list comprehension. List comprehension, Python. So real Python, maybe this one. So this is basically list comprehension is basically how you use a for loop. So let me just show you some example using for loop in Python. So for example, here I have a list, right? So list comprehension is used to make a list. The most common type of for loop is this: initiate a list here, and iterate something like this. For I in range of 10, create a list, something like this. But there is what is called, you can also use map object to create a list, but this is one of the best now people using, which is list comprehension. So what this is telling you is that, for example, you give an example expression, then for member in this in iterable. So for example, here you have for I in the range 10, that is for I in range 10, return I times I. So what is range 10? Range 10 means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is range 10 from 0 to this. So for I in range 10, the first return I times I. So the first one is 0, return 0 times 0, which is 0. The second one is what? I in range 10, which is 1. 1 times, return 1 times 1, which is 1. The second one, third one, which is 3, in this range 3, return 3 times 3, right? Okay, is it 2? Okay, 2 times 2, which is 4, something like that. So this is list comprehension. If you are not familiar with the list comprehension, we treat this one in our previous sessions on Python. So yeah, so here, this is what we are saying here, the same example. Right, so we say here for car in test, so for any character in test, if the car is not in string manipulation, then return that car. So what is telling us that is, okay, this one, we take the first one, which is this, right? $sign for car. Now our car is $sign in test. If car is not in string punctuation, return the car. So, but this our $sign is in string punctuation, right? It will not be returned. So we'll not return it. So now we have that one. Now after this, let me show you what will happen. So we have this. Okay, so now we have this. So let's look at what will happen now. Test, punctuation remove. What is the result? So can you see that the first one is this one is inside this, it's not returned. The next one is I, is returned. The next thing is what? Space. Can you see space? Because space is not here, it's also returned. The next one is L, is returned, O is returned, something like that, right? But that is not what we want. We want to put the text back. So we don't want to see them in a list like this. I want to put them in this. So we can use join function in Python. So this one that is returned here, I can use join. Then I can put this one, test return, join everything in test return with what? Space. So let's look what will happen. So I use this is a space with dot, join everything and remove and put them into test this join. And now let's look what will happen. So can you see that we have this? Can you see? So here, this is telling you you are not using any space. You are joining them, right? This without any space. If I have this, I have a space. Let's look at what will happen. Can you see there is space between each stuff? But this one is like there is no space. So it put everything together. So any question before we continue on punctuation removal? Any question before we continue? Right. So if there is no question, let's continue. So now you can see here we have I love AI machine learning. So we remove all this $sign. We remove this. Can you see this sign, stuff like that? So we have this. So this is one thing. So what are we doing? So we are trying to remove anything in our test which are actually punctuation, which is one step in doing sentiment analysis or test classification to remove punctuations. That is what we do down here. But we also have another step what we can do before we do that. Right. So which is basically remove stop words. So that is what is called stop words. So the first thing now we have seen is to remove punctuation, which they don't actually add anything to our data set or to our corpus. But there are other things that are called stop words. So for example, if you look at this sentence, I love AI machine learning. This is okay, here we don't have many stop words, but let me show an example. So that is what is called stop word in machine learning. Does anybody knows what is stop word? Does anybody knows what is stop word?
Yes, words like this.
Okay.
Yeah, I think no.
Dr. Idris, Kazuni.
Yes, sir. I don't. So I think stop words is what's in the they just fill up this thing without making much, contributing much information. Like is, like a, like words that are just plenty, but don't really have
yeah,
much contribution to this thing. So
yeah. So stop word are basically some kind of words that actually don't contribute to your models. But in some ways, the considerable what we are doing now is we are trying to remove all the stop word like is, are. In Hausa, we have da and stuff like that. So in our project, I think in our project we have the stop word. I think I have not uploaded the stop word. Um, okay, we have number 6 stop words in all these languages. We will upload the stop word here. So basically, you can also do your sentiment analysis like in Hausa, then with the available stop word. We have not uploaded the stop word, but we'll do that. So these stop word, they don't actually contribute to anything to your corpus, right? To do sentiment analysis. So for example, if I have a text like this girl is this girl is beautiful, right? So this girl is beautiful. So when I remove this, when I remove this, girl beautiful, does this tell me this sentence is positive or negative? Yes, this tell me this sentence is positive because there are some beautiful word in it, but without even with this girl is positive, but it increases the space of your futures in machine learning because we want to create some futures. So it's good to remove these kind of redundant words that actually don't contribute much to the your stuff. So this is kind of words are called stop words. So now there are stop word, existing stop word that you just need to download. You don't need to create. For example, we have a package called NLTK in Python. So if you don't have this NLTK, you need to install it to use it. So for example, NLTK. So this is NLTK toolkit. There are many stop words from different sources like Jensen, Spicy, many stuff like, but this is the basic one. So you can come here and install NLTK. So here you can say, okay, NLTK, pip run install, pip some stuff like that. But I think with Anaconda, maybe NLTK is already installed. I'm not sure. You can check that. But basically, NLTK is a Python package that but also Spicy. You can see stop words here. So yeah, Spicy also do have stop words that you can actually use. Not only Spicy, but there is also Jensen library. So with Spicy, you can do a lot. There is also Jensen stop words. Right. I don't know if Jensen has it. So basically that is it about that. So we want to remove all this stuff. So here I import NLTK library and I download the stop words here. Yeah, so here from NLTK corpus import stop words English. So you can specify the language you want to work on. The one we want to see here is English. So you can see these are the stop words. I, me, my, myself, and stuff like this, or yours, all this one are called stop words. So what I want to do now is after removing those kind of alphanumeric kind of stop, what do you call punctuation? I want to remove all stop word in my sentence. So here it means I love AI and machine learning. I want to have only love machine learning. Maybe I should remove it because it is in stop word. So the same way we do with removing of punctuation, we can do that. So for car in test, which our test is this, if car not in string manipulation. Okay, this is the previous example we saw for the that we saw for removing the punctuation. So let's look at this is a join that we saw. We join everything. Okay. So I want to explain something here. I think so. Here you remember here what we do, right? What we did, right, to remove punctuation from this stuff. And here, as we can see here, we remove the punctuation. But this test, we can also split it into what? Using a word called split in Python. So when we call this split function on this tag, on this variable that gives us this, it will remove, split this sentence into a list of words. Can you see it? It split them, right? So here we can call it now on top of this function previously, and it can do that. So what I want to do now is I want to split this sentence into remove the stop word. So I have like a sentence called here, I enjoy coding, programming, artificial intelligence. So I want to remove stop word from it. So for me to remove stop word, so I say here for word in test function, remove join the split. So what is this? This is this one, right? Where it returns the actual word per word, right? If word lower, so word lower, it means whatsoever it is here, this word that are returned, it will take the lower case of this word, because the stop words here we have, they are all in lowercase. Can you see that? Me, myself, stuff like that, everything is in lowercase. So I want to make sure that all the tests I want to compare, they are in lowercase. You can see here, machine is not in lower learning, I is not in lowercase. So here, for word in test, this, if word the lower, not in stop word English, then return the word. So for word in test function, remove join split, which is something that will be returned like this, right? It will be something to return like this each word. If word that lower, that is every word that is returned is lowered, not in the stop word English, then return that word. So you can see when we run this, we will have something like this, which return is test point. This is what we return here. So when we run this, so you can see enjoy coding programming. We have enjoy coding programming, and it's removed. I is removed. All right. Yeah. So anything, anyone with question, or anyone, do you want to add anything?
Yes, I think maybe it is worthwhile mentioning here that for natural language processing task, we don't do like the same data pre-processing. So in
yes,
in sentiment analysis, we might not need stop words, but in tasks such as machine translation, you need every information that is in the sentence. So I think this is just what I want to add.
Yeah. So this is something good. So different tasks you do for stuff require different kind of how you can prepare your data and stuff like that. So for sentiment analysis, in some ways we need that, but not. I mean, even for deep learning, we don't actually remove these stop words. They make sense in some ways, but we can come to that. But for now, for this basic machine learning, because we want to construct features in machine learning, so we want to reduce the space of the features to some kind of manageable stuff. So yeah, any question before we move on? Right. So don't forget, what we are all trying to do is we want to construct our future, our future stuff. So let's do what is called vectorization. So
Yes, Doctor.
yes, go on.
Before you move on, I see that you use the split. Were you trying to remove the double space?
No.
You use the split function here. Test punct remove dash join dot split.
Split. Okay. So here, this is the I love AI machine learning. I love AI. Split is the one that split this sentence into a individual or something like this. Can you see that? Because here I said, okay, test from remove the join split. It will give me an individual word. This one will give me a single word. And I want to lowercase the word, right? And see that it is not in stop word English. So this split is actually trying to put every word in a single list. Does that make sense?
Yes, yes.
Okay, so let's look at something. So machine learning algorithms operate on numerical features. A certain input two-dimensional array where rows are instances and columns are features. So I believe I know you have not forget something we discussed. Basically, what we discussed previously, if you remember, is this: we have columns where they are features, right? All the columns are features, right? And the rows are the instances. Is that correct? Do you remember this? The columns are the features, and the last column, one column is called. Okay, who can tell me in the way we prepare our machine learning data set when we discussed previously? We have many features. The columns are called what? We have different kind of column, right? The first one is called feature, and the last one that we want to predict the column is called what?
Target.
Tiger, right? Now the rows are called what? Okay, the rows are called instances or records. So each row is a record or instances, or yeah, and each row, each column is like features, and the one we have the one column, the last one, which is called the target. So you remember all those features are numbers, right? So but here what we have here, because we are dealing with text, all our features are text, like love, stuff like that. So in text analysis or natural language processing, we always try to change all these words into equivalent of words. I mean, numbers. We need to change these words to numbers. So machine learning algorithms operate on numeric features, expecting input as a two-dimensional array where rows are instances and columns as features. Remember this. In order to perform machine learning on text, we need to transform our document into vector representations that we can apply numeric machine learning. This process is called feature expression, or more simply vectorization, and it's an essential step toward language aware analysis. Yeah. So if you want to do anything on language or text, you need to change this text into some kind of features, maybe vector representation in some ways or whatsoever. So yeah, so we want to see some ways. So let me show you what we mean by that. So for example, now I have 3 sentences, 1, 2, 3. Now, all these sentences, I want to do maybe sentiment analysis or some stuff like that. You cannot do sentiment analysis on this sentence, which are characters. You need to change these characters into equivalent word numeric representation. So the first thing you need to do is, for example, you need to create a single row, for example, vector. Can you see I create a single vector? Now, each word, I will put it in this vector. So here you can see I have the, this is the Z, I have elephant, this is the elephant, right? I have elephant, right? Elephant, sneeze. So each word, all the words that are here are now they have a single column like this. So all these words, so if a word is replicated, for example, the, I have the in this one, I have the in this one, I have the in this one, but I will not write the 3 times, right? I will write the, where is the? Do I have the? Yep, I have the, right? I have one the here, right? But what can I do now here? So what you can do is, if I look at this one, if I look at this one, where is my B? Okay, this is not the right, this is not the right, what I want to put. So what I want to put here is this. Let me see it here. I have the vector coding. Let me see this. Not this. Just give me a second. Okay. Right. Maybe. Okay. All right. Let's go on. Maybe. So in essence, let me just explain it here. Oh, not this one. So for example, now if I have this one, the first one here, the first thing I need to do is represent all these words that are in here in some kind of single vector. And now, okay, in this one here, I have at. Yes, one at. Do I have but in here? No, it's 0. Do I have can here? No. So everything that is here, you update its value to 1. Now maybe I can move again. Let me go over. It is okay. So what we can do here is that after we finish everything, like here, you can see here the word but. The word but here, I have 1. Do you have another but? But yeah, I have 1 but. I have 1 but here. Can you see here? We have but you can see that the but here, this is capital but and with S, and here we have but without S. So we do what is called tokenization or some stuff like that take the stem of the word. So we have 2 but. So here, what in essence, what I want to say is that we need to create a single vector that count the number of words we have. So this I took a wrong picture. The picture I wanted to took from the web is that if we have this single vector, then we have like for the word Z here, I have 1 Z here, I have another one 2, then I have another one 3, then I have another one 4, 5. Then here when I have Z here, I will have like 5 Z. So it count the number of the Z we have here. I took the wrong picture from the web. But in essence, what I want to try to say is that when you have a text, what we do is this. We transform this collection of text into some kind of form of vector that shows the maybe representation. Where we have what we call one hot vector encoding. We have some stuff, a lot of stuff, how to do with the vector representation. There are different ways, but one simpler way is called one hot vector encoding. So fortunately, you don't need to do this manually. Scikit-learn provide you with what is called count vectorizer. So count vectorizer, basically what it does, let's see it. What count vectorizer does is something that I'm saying. Let's look at it here. So future extraction. This is what I told you is called future extraction. So given a text, remember, given a text, you need to extract future from this text so that you represent it in a way you can train machine learning, because you cannot train machine learning with this text like this. Saboda baya gane wannan. Kun gane abin da yake nufi? Abin da yake ganewa shine text din. So canja wannan text din into another form that machine learning can understand is called future extraction. So this is future extraction text, but future extraction for text, right? So we have what is called count vectorizer. Convert a collection of text documents into a matrix of tokens. Can you see that? Convert a collection of text documents into matrix of tokens. Okay, let me show you something. Count vectorizer. Yeah, so this is another example, a good example. So you see here, for example, I have red. Okay, can we see all this? Let me open it here. Okay, so can we see all this? I have red, yellow, green, yellow, right? So when you want to construct your future, we have red. Can you see red? I have yellow, I have green. Now, in the first document, our rows are document. The first document, I have red, then I can put 1. Do I have yellow? No. Do I have green? No. In the second document, I have red. Do I have, I can put 1. Do I have yellow? No. In the third document, so this document maybe it's a collection of tweets or something like that, a long list of words, but just this give you an example of single word. I have yellow. So in red, I can put 0, but yellow, I have 1. So this is what we call in some way one hot encoding or count vectorization. Yeah, so this is basically what I want to try to say. So scikit-learn actually allow us to do that. You can see convert a collection of text document into collection matrix. So what we can do with that is this. You can do it in scikit-learn. So you can do it in scikit-learn in this way. you need to import the count vectorizer, and this is a sample of text. Sample of text I gave you. You can see the first one with comma, the second one with comma, the third one, and the fourth one. Then we can create our object count vectorizer. We can create an object called vectorizer, and now we can fit the vectorizer, fit transform. We already know this from our previous. Then you can put your data, which is sample data. Now we can train this one. So when we can train this one, this will do what we call our feature extraction. And now we can see, okay, let's look at our features now. So now what are our features now? So our features now are and document first is these are features. So where do we get this one? This one I get from this one. So you can see we have this, right? We have this. Yeah, this is the this. We have is, right? We have is. So you can see we have this in this first one. We have this in second one. We have this in the third one. We have this in the third one, right? In fourth one. But we have only one B, right? So this is the way we represent it. Maybe the similar way I showed you here. We have red in this. We have red in this. But we have only one red here. So we put whether the red is available in the first one. We have 1, 2, or something like this. So this one also, this count vectorizer now it creates a matrix like this. You see this matrix. So count vectorizer creates something like this matrix, which is this. So this is the matrix. This is the matrix because you can see that here we train the count vectorizer. This is the matrix. So can you see sparse matrix with how many rows? 4 rows. And how many columns? With 4 by 10 features. We have 1, 2, 3, 4, up to 10 features. But how many rows? 4, because we have 4 documents. 1, can you see 2, 3, 4? We have 4 documents. So how can we see the matrix? So we can change it to array, so that we can see it. So you can see here 1, 2. This is it. So you can see here, this is what we have. So we have the first feature, which is and. So in the first document, do we have and? This is the first paper. Do we have and? We don't have and. Then this is 0. Can you see that? What is the second feature? Document.
Document.
Do we have document in the first? No, we don't have document. Can you see it's 0?
Yes, it will be 0.
Then the third one, which is the third feature? First. Do we have first in our first document? This is the first. Can you see we have first? Can you see we have 1? So because we have 10 features, 1, 2, 3, 4, up to 10, we have 10 here, and we have this. So this is now our future vector. This is what we can train machine learning with now. So in essence, now what we have seen is this. If we are doing machine learning with text data, not numerical data. So if, for example, you are using machine learning, your problem is using text numerical data, you don't need these steps, like to change your text into this format, because maybe you are counting the distance or maybe parameter of something or length of something. You already have like figures like this in numeric. But in text analysis, like sentiment analysis, you need to change your data set from text into this kind of format. This is the way machine learning can understand. You cannot do any machine learning with this text. What you need to do. Any question before we continue? There is anything you can add?
I think it's okay. Maybe when we reach other maybe alternatives to one-hot encoding, maybe I might say something about
Yes. You can. You say what? You want to say something an alternative what embedding?
Yeah, I said there are alternatives to this, but maybe there is not. We did not reach the.
Yeah. So this notion of changing the word characters into some kind of numeric value, there are different ways to do that, and one of the recent one of the widely used approach now is called embedding. Okay, I'll show you. So for example, we have what is called Hausa embeddings. There is sunan paper nama Awiko.
how's our embedding for
So, for
NLP?
example, so this is the work of Dr. Idris of Hausa embeddings, which basically is the embedding, changing this kind of stuff into kind of vector representation. But what we are doing now is just some this is just what is called count vectorizer, which basically do one whole call embedding. But there are many stuff like that, but we can see more in the future. So now let's move on. Any question? If there is no question, the next thing we need to do is like to put, yes.
Good afternoon, sir. Hello.
Yes, go on.
Yes, sir. What are the stopwords in House NLP, please?
Right. So in House NLP, we have a stopword. So the stopword, top stopword in House NLP is da, D-A, da. So as I said, we have this project called Niger Senti, which we develop corpus for sentiment analysis. I will upload, because before we do that, we had to create Hausa stopword. I will share these links with you guys so you can get the Hausa stopword. I have not uploaded it yet, but I think I was thinking like everyone, it's not that a big deal, but people can, and many people may not have those stopwords. So we have the stopword for Hausa, and we will upload them here. So I will share the link so that you can get into this website, get the Hausa embedded. And this is our paper, and we discussed the stopwords for the Hausa, but we didn't actually do much talk about the stopword in Hausa, but we actually use stopwords to collect tweet from Twitter. So you can you can check this one. I will share the link so you can check this one. From number 6, I will put the stopwords in Nigerian languages: Hausa, Yoruba, Igbo, and Pidgin. So you can use that. Yeah. Any question again? Alaikum salam.
It isn't a question, sir, but a request for Lee on behalf of all of us.
Yes.
We are requesting that before the end of this sentiment analysis class, that you give us a brief guide on how to collect this Twitter text.
Yeah, sure. So if you are happy with that, I can do a session tomorrow on how you can even do like tweet collection from Twitter directly. I can, yes, I can give session.
Suggest, sir.
Yes.
I think they should first, as an assignment, read the paper on that link so that they will get familiar with the process.
Okay.
Then you
yeah. So we have another paper, but the reason why I didn't want to like I wanted to remove the paper because we the Sebastian we want to upload the author. So there is one author that we missed. We want to put in. So this is our paper called Niger Senti. So you see, we have like how we collect the Twitter data, a lot of stuff. You can read the paper. Yeah, so this is our experiment. You can see the number of tweets. We have everything. You can see this is our experiment, language models like BART and stuff like that. We do cross-lingual transfer learning and stuff like that. Yeah, so basically this.
I think if it will be too technical, I think they can read the sections only that talk about data collection and pre-processing, and maybe as we go, we proceed into the lectures. I think they will be getting familiar with all.
Right. So maybe we will, as I said, we will have maybe a session where we will be discussing research papers. So maybe we will discuss the detail of this paper, but be assured that the paper will be updated because it's not the final version. We will upload the paper. So maybe, yeah. So let's move on before that. And also tomorrow, I think we can organize, maybe if you are using Python or R, I will walk through all the approach you can get tweet from Twitter in any way. So let's move on quickly and finish this session. So it's all time. So now what we are doing in essence is this. we have not yet trained the machine learning model, because training the machine learning model is simple, right? In just 3-4 steps, lines, we train the machine learning model. What we are trying to do is, they said in data science, what is in machine learning and software learning, also in data science, 80 or 75% of the task is data preparation, trying to put your data in shape that you can do machine learning. So doing the task, training the model it's not that hard, because like, for example, with scikit-learn, everything is ready, but putting your data, cleaning your data will take you your time, 70% of your time. That is why you see here we are spending time trying to put everything together. So don't worry if you are like trying to actually see we are taking time, but this is how it is. So let's go on. So what we want to do now is that create a pipeline to remove punctuation and stop word and perform count vectorization. So you remember we remove punctuation, we remove stop word, and we do count vectorization. So what we want to do is like, we want to put all those steps in a single function so that you only call the function. So here I call a function called method cleaning. So because we are doing cleaning, I'm removing punctuation, I'm removing stop word, and also doing count vectorization. So here I have like method cleaning is function. I have an input here. Here is to remove the stop word punctuation, which we have already seen, and here to join the text, and now here to remove the stop word, right? And now here to return this one, to return the text after I remove stop word. So this is this one. So you see here, I have my tweet df, and now call under tweet column, and now apply this method cleaning, right? This one, method cleaning, which is a function that do remove punctuations and also remove stop word. So instead to do everything in a single line, in one line, I create a function that do everything. Now I apply this function to the column tweet, but this one I will not run it. It will take like, because the tweet are like 3,000 or 4,000, it will take like more than 10 minutes to run. But now when everything is run, it means that all this function that is now applied to it now clean all the tweets. Now when let's see the sample of the tweet. Tweet number 5, you can see this is the tweet number 5 after cleaning. But also before cleaning the same tweet, look at the tweet, because here is df clean. I have df clean here, but the original tweet is tweet df. You can see it here. There is 1/ here. There is like huge font, and there is they. Can you see they are all removed here from the tweet clean? So here I have now clean tweet, which basically remove punctuation, remove stop word. And now what we need to do is like to just do the count vectorization to create the futures. So let's move on. So now we now have prepared our data, clean data, which is called tweet clean, where there is no punctuation, there is no stop word, which is this. So let me see it here again. Tweet df clean. So you can see that this is the tweet df clean. This is the tweet number 1. You can see tweet number 1. This is the way it is. Can you see that? It's this format. There is no and I remove everything. I remove the punctuation. I remove those stop words. This is how it is. So now I want to do count vectorization to create the futures. So from scikit-learn, can you see that I import this count vectorizer? Now count vectorizer, you can put analyzer, which is message cleaning, and now the type. So what this is telling you is that the count vectorizer, you put something called analyzer, which we put a function called method cleaning, which actually will apply the method cleaning function onto your text that you have. So this, you create a vector, you create your object called vectorizer. Now we create the tweet vectorizer. We call this object vectorizer fit transform. Then we put our data set, right, which is tweet df tweet, the column tweet. We want to create vectorize. We remember this column, all right, which basically used to create our futures. So now something similar to previous one. Let's see the future names. You can see the future names here. We have them a lot. You can see them. I did run this one. Let me run it. Huh. Okay, it's running. This one is the last one that we did. We show the right. So when we finish everything here, we put our tweet into kind of this kind of futures into row into numbers. Then we can just train our machine learning model. We are running out of time. That's why I already run this up, because this one is like large and it takes time. Oh God. So any question before that? Before this finish running? Oh, Data, you want to add something?
I think it's okay, sir.
Okay. So so for anybody that want to know how to like do tweet, grab tweet from, there is a package called twerk tweet. Which is basically a command line tool that you can also use Python. No, let's look at this one here. Yeah, we can have a separate session. I will show you how you can use so which is basically simple. You can install it here, and there is twerk 2. There is twerk 2, which is basically based on academic Twitter, or twerk 1. So different version used with different stuff. When you install it and configure it, so you can search tweet like twerk 2. Just to collect tweet, you can say twerk 2 search Black Lives Matter tweet.json. So this one will download all tweets that have this Black Lives Matter. It would save the tweet in JSON this way. Can you see that? It's so easy, right? So for example, this will download tweet, search Black Lives Matter or BLM. This query can be a lot more than merchants. For example, query with submit containing Black Lives Matter or BLM. So there are a lot of, so this is very, you can limit the number of tweets. So for example here, tweet towards that limit, you limit the number, you want like 5,000 tweets, Black Lives Matter, any tweet that contain Black Lives Matter, and save it. So you can see this, and you run this in command line. So this is basically a simple stuff. Okay, let's see whether this guy finished running. Is he still running? Go down. Let's see. Right.
I think in that twerk I saw archive. So I don't know what that means, sir.
Archive. Okay. So what means that is that when you are collecting tweets, there is what is called archive. What means is that there is different kind of Twitter account that allows you to grab tweet. The normal account for Twitter, if somebody just signed, it allows you to get Stream API, which allows you to get tweet like in the last 7 days or current tweet or last 7 or 9 days. But the academic API allows you to get archive tweet, historical tweet, maybe for since 2006, allow you to get that stuff. So I think that's what they mean by that.
Okay, thank you.
So this guy finished. Oh, this guy is still running. So let me just hover on so that we can see, because I think I run all other ones. So you can see here when this guy finished, when we run this one, this is actually the vector representation. So we have, so as you know that because we have many column rows, this dash means there are some stuff in between. Yeah, so this guy is still running. So when we finish that, right, so we can look at the shape of our tweet count vectorizer. So you can see here is our tweet count vectorizer, right? Tweet count vectorizer, that is what we fit. And now we have this tweet count vectorizer, this is what we have, right? So now we want to see the shape of this one. So tweet count vectorizer, what is the shape? So you have these 9 rows and you have this column, right? This is the shape. Now, I want to change this tweet convert rather to see it in data frame. So here is tweet convert rather to array, which changes to this format, this guy into this format. But I want to change this guy also to data frame. So I can call the pandas data frame, pd data frame, and save it into X, and now call X. So now this is in pandas data frame. So this is actually what we already know, how this is the standard way we saw how you can put your feature in row. So this is our features, right? All this one are features. These are all rows are instances. So each row is a tweet. Each row you see here is a tweet. Each row is a tweet. And what this means, so this is row 1, 0, because Python, you know, pandas start with 0, 1, row 2, row 3. And each row is a tweet. So what means the first one here, row 0, is a word, it's a feature, which this guy is still running, we should know, but it represents that feature with 0. It is a word or something like that, or something like or good. So it represents that with 0. So this 0 or whatsoever the word is, maybe good. So each tweet that has good, for example, then we can have 1. But you can see all here we have 0. So all these tweets we have. So you can see here we have all the tweet 3,000, 31,000 something tweets. And now the first feature now here in this 1, 2, 3, 4, 5, we don't have that word at this, and in the last 5 we don't have that word. So this you can see almost this matrix is sparse. It includes many zeros, and we have what is called sparse matrix and how we can deal with these features and stuff like that. But now the idea is for you to know that everything column here is the feature. Every row here is the tweet or instance. So now we have our full feature, right? Now what we need to do is we need to have our predictor level. So you remember the tweet df, we have a column called level. That level, you remember, let me show you if you forget tweet df, what tweet df is. Oh, it's running. The other one is running, and I'm running. I'm sorry about that. So tweet df, I would already know, is a data frame with column called level, and that level, you remember, it contains 0 and 1, right? 0 means positive and 1 means negative. So here I now extract that column and put it in Y, and now here this is our column, right? Can you see that? So this is our predictor. So now we have our X. You remember here I say, okay, this is our X, which is our future, and Y is our what? Now our predictor, right? So now we are becoming into the good shape that we can train our machine learning. So train and evaluate naive-Bayes classifier. So now we are now done with preparing our data set. As I already told you, in doing machine learning or data science, 70% or 85%, the task involved is preparing or putting your data into a good shape. Cleaning your data and preparing your data, what is called data preparation, is, as they said, 90% is that data preparation, data science. Let me see. Percent. Data scientists, according to interview and experts, spend 50% of to 80%. Can you see that? 50% to 80% of their time made in the mundane labor of collecting and preparing a really detailed data before it can be explored for usual nuggets. Can you see that? So this is actually true for data set. In fact, before we do collect our data set for this, our work that we have just shown you, it takes us like to collect this data set like for almost like more than 6 months to prepare this data. So you can see here like data clean, data loading, data cleaning, data visualization, model select. So you can see like small model training, just 12%. Can you see that 12%? So all these steps, they are the mundane tasks. you need to know how to do that, to clean the data, to do some visualization. These are stuff that takes can you see some stuff like that? Percent time of data activities per week, some stuff. So this is something that you should know, that you should data is good, is well prepared, is well presented, then you will have a good model. Because a bad model, one of the things with bad model is that it does have the bad data. So to have a good model also depends on your data set. So yeah, so you can see we have our data set, which is X. We can see we have this row, this is the number of columns. But the Y also, you can see, you remember the Y and X, they must have the same number of row, right? The same number of shape. You can see they have the same shape, right? This is number of row, this is number of row. So we can now split our data set. As usual, we know X trend, X test, Y trend, Y test. As usual, we have been doing this. Then we call our trend test split with our X and Y. We say, okay, the text size is 0.2. So you can see it will train our data. So here we have now our trend data set. As usual, this is not something new. We call our multi-naive naive Bayes classifier, scalar naive Bayes simple multinomial naive Bayes classifier, and we now train create an object called NB classifier. Then we now train NB classifier dot fit trend Y trend. Can you see that now with fit and trend? Any question before we continue on fitting the data set? Any question? Falalu, any question?
No. Sir?
Okay. Yes, no.
Sir, I observed that some data sets come with this splitting.
Oh, yeah.
So how do we do that? Thank you.
Yeah, so good question. So she's asking, some data set comes with this split, stuff like that. Then you don't need to do the split. You already have your split, like the trend test and stuff. The reason why here you split is because you don't have them. You only have a single data set, and you want to divide this data set into 4 classes, which is S trend, Y test, Y trend, Y test. So if you already have the training set and you already have the test set, then you can divide them into this kind of format and assign the value if you want to maintain this kind of nomenclature. So yeah, if you already have your data set splitted, then you don't need to split them. You already have them split. So this is useful. For example, if somebody training the machine learning, they will release the test set and train set the way they do split. So if you want to reproduce their work, then you need to do exactly the way they do the training set and test set. Yeah. So yeah, any question? Yes.
Yes, I don't know whether it has been discussed previously, but how do we select the right algorithm or the right to fit the data?
All right. Yeah. So this is what we have discussed in our previous sessions. We do what is called supervised machine learning. We discussed a lot of them, their advantages and disadvantages, how we can use them. So what I want to do here is I choose okay. So if somebody can remember, each algorithm that we take, we look at its advantage and disadvantages. Like okay, let me show some stuff like this. Okay, so yeah. So for example, this is naive Bayes algorithm. After we finish, this is what we did previously, I think. Yeah. So after we finish, we discuss some of this. Okay, strength. The naive Bayes model share many of the strengths and weaknesses of linear models. They are very fast to train and predict. The training point is easy to understand. The model works very well with high dimension sets, and data are relatively robust to the parameters. So you can see that naive are great baseline model and often used on very large data set where training even linear model may take longer. So in each data set, in each algorithm we discussed, and previously we discussed some of the strengths and weaknesses and stuff like that. So based on that, one can actually choose the right algorithm you can work with. So decision tree as well, many stuff like that. But as I said, one good thing, what I discussed previously. So if you are using, for example, you are doing machine learning and you are doing sentiment analysis, as I already discussed, is that try to read the papers and see, okay, if I'm doing machine learning and what I'm doing in machine learning is sentiment analysis, which algorithm in machine learning works best in sentiment analysis? Which algorithm works best? This is simple in literature. There are many and stuff like that. And now that will give you informed decision. Okay, when I want to do sentiment analysis, always I will be using naive Bayes. So naive Bayes is one of the good thin baseline algorithm that is being used for sentiment analysis. But if you go further, what we be doing, I think the strong point of doing that is to have data performance is using what we call ensemble approaches. So ensemble method, I think something like this. This is one of the ensemble approach. Ensemble. Okay, so we discussed ensemble approach, which we said these are the algorithms that even makes the win the Netflix prize. So even in what do you call it, in Kaggle, ensembles algorithms are the ones that really win a lot of competition in terms of machine learning. So one good thing is like to use ensemble method to change some algorithms, stuff like that. That would be a good. But for at the baseline, naive Bayes is a good decision. It's a good algorithm to start with. So I'm not saying that now you should always use decision. It's up to you to train your model with different algorithms and stuff like that. Yeah, I'm trying to look at where we discuss ensemble method. Okay. Right. So this is it. So okay, let's continue. So here we train the algorithm, and now we fit with that. You can now predict on X test, as we already did. You can predict this on X test, and now you can now find the score. Okay, let me see whether this will, maybe you can run it yourself. This will take us a long time for it to run, but we already know how this works. So here I do this. I create my object called my NV classifier, and now I fit it here, right? But one way is for us to use the score function is to use the object, fit on trend and Y trend, and predict on X test, right? When we predict on X test, then we say this is Y predict, right? Y prediction, because we do it on test set. Now we can find the score using this function. NV classifier, we call the score, and we say X test, and Y test we call the score function, and this will give us the accuracy on the task. Yeah, so you can run it, it will run, but this will take us time if I run it. But also what we have not discussed is using classification report. Maybe tomorrow we can discuss, but we can leave it. What is called confusion matrix. I do it here, where we have what is called precision recall, F1 score, and support. I will explain these ones tomorrow. We can stop here. I think we are running out of time. But here also I use ensemble. I wanted to run ensemble method using gradient boosting classifier. So there's something like now create a model called gradient boosting with model. Now we can fit the model, right? And now we can predict on X test, right? We have Y predict, and now we can now calculate the confusion matrix, and now we can do some stuff like that. So yeah, so this is actually, I believe the training of the model is not something that we should, it's something that we have already been seeing since the beginning of the sessions that we have been talking about. This is not something, I will share the notebook, you can run it. But most importantly, what I will do is I will share this notebook, and also I will share with another data set. I will share another data set, which is from Amazon Review. And what I want you to do is to replicate this sentiment analysis on another data set that will give you the same step. The same step. I don't want to, I mean, what I mean by the same step is just to follow it to, it will force you to use your hands to understand something. If you don't understand, then you can ask in the Slack channel. So I will share another data set, replicate this sentiment analysis from the beginning to the end to see that you understand that. As I already said, if you don't practice this, like doing project with your hand, you will just like go, you will not understand it fully. Yeah, so any question or anything to add? from anyone?
How about the previous lectures?
Oh, I will. What do you mean? Upload them on
Yes, upload them.
Okay, I'll upload the previous lecture. I'll also share the notebook as well.
Okay.
Yeah. Any question again? So maybe tomorrow, we may see. I will expect you, please. I will share the data set that I want you to replicate. I will share this notebook, and I will expect you, please, to run the machine learning model tomorrow, before tomorrow, so that when we come, you can ask questions. Please and please don't be shy. Try to do this stuff and ask questions. You run into troubles and you learn from the troubles. When you learn from the problems you encounter, then that's where you learn. But when you assume you just learn, then it will not make any sense. You will just be here just listening to people without understanding a lot. So I will urge you, please, when I share the data set and the notebook, please replicate the example, ask question along in the channel. Tomorrow it's a good way to ask questions. And also tomorrow, maybe I will run another sentiment analysis, maybe different from this one, so that we'll have a full understanding of that. And maybe I can run a separate, maybe if we have more time, how to collect tweet maybe online using some stuff like that. Yeah. Any question again? There is anything to add? Okay. So if there is no question, and thank you very much for joining, and we'll see you next week. I mean tomorrow. Sorry. Okay. Bye bye. See you all tomorrow.